Hi, my name is Jacob, and I'm here to talk about probably the most famous paradoxes of the four today. It's known as Olber's paradox. It questions how an infinite, ageless universe could be mostly dark. But at first glance, it seems pretty obvious, right? The more distant a star, the dimmer it is. So stars that are very far away are simply too dim to be seen. But the apparent brightness of a star follows a specific relationship known as the inverse square law. A single star some distance away is as bright as 4 similar stars at twice the distance, or 9 similar stars at 3 times the distance. But if stars are distributed fairly evenly, then that means there would be 2 stars at 4 times the distance, or 9 stars at 3 times the distance. Completely opposite. So while the stars appear to be dimmer with distance, there are more stars at a greater distance. So that infinite, ageless universe should have a sky just about as bright as the sun.
Hi, I'm Michael, and I'm going to talk about the Hilbert Hotel and Infinity Paradox. Let's say there was a hotel with an infinite amount of rooms, and each room had a person in it. The hotel is full, right? So there's no way you can put any more people in this hotel. If a customer comes to the hotel's reception desk, the manager has a way he can fit him in the hotel, and it's quite simple. All he has to do is tell the person in room 1 to move to room 2, and the person in room 2 to move to room 3, and the person in room 3 to move to room 4, and so on and so forth. Everyone gets shifted one room. There's an infinite amount of rooms, so you never run out of rooms. After he has done all this, room 1 is free. You can actually put as many people as you want in this full hotel. You can even put an infinite amount of people in this hotel.
Hi, I'm Tim, and I'll talk about Gabriel's trumpet. So imagine you have a trumpet, but one end of the trumpet comes to an infinitely small point. Now, with that being said, that would make the inner surface area of the trumpet infinite. Now, let's say somebody wants to buy the trumpet, but for some reason they want the inside of the trumpet to be white. Now, that's not a problem because all we would need to do is buy white paint, pour it down, and the entire inside would be covered. Now you can see where the problem is, right? We have an infinite surface area, but we're able to cover it with finite quantity of paint. Now obviously this is a hypothetical situation. In real life, paint is very thick and would not be able to fit all the way down. But if the molecules of the paint were infinitely small, then we'd be able to cover the inside entirely.
Hey everyone, it's Juan coming to you live talking about Zeno's paradox, and today I'm going to be explaining this paradox through a story called Achilles and the Tortoise. Now suppose Achilles is in a foot race with the tortoise, and Achilles gives the tortoise a 100-meter head start. And so after a finite amount of time, Achilles will reach the starting point from where the tortoise was at 100 meters, and by that time the tortoise has moved 10 meters which leaves Achilles at a distance. It will then take Achilles some further time to run that distance, by which time the tortoise will have advanced farther, and then more time still to reach another point that the tortoise was at, thus giving an infinite amount of points which Achilles has to reach in order to reach the tortoise.